Today's lesson is 7.9, the base E and natural logs. Okay, so this is probably a new thing to you. What is E? The letter E that we see here, E is an irrational number, and it has an approximate value of 2.71828. Now, the reason why this happens is it's something that occurs in nature dealing with growth situations. So E often is used as the base of exponential and logarithmic functions. So instead of a base 10, we'll see a base E. And it's used with real world situations. A lot of times it comes up in nature, which is unusual that nature would have a common, kind of like an exponent almost. And so that's where we're using the E. Now, exponential functions with, where's my undo button? Exponential functions with a base E are called natural base exponential functions. So an example of this would be if we had f of x equal to e to the x power. Now this is something that's actually on your calculator. So let's go over to our calculator feature and check this out. Okay. Now, over here, what we have, let's clear the history. Okay. On the left side of your calculator, right behind the button that says LN. So we have our number 4, which you can see. And just to the left of that, we have this button LN. This is our natural log. We're going to see this. Now above the LN or natural log button is blue. So if we hit second and natural log, we see E come up. If we set it to the 1 power, E to the first power, we're going to get that 2.718 number. So that's on our calculator already. All right, so our base E exponential function is f of x equals e to the x. Okay. Now, if we want to see this as a logarithmic, those are called natural logarithms. Okay, instead of a base 10, they have a base E. So an example of this we might see as a function could be f of x equals log with a base E of x. Okay. Now, this log base E, or what we call the natural log, we're going to abbreviate that as LN, which stands for natural log. And so we'd see it like this. F of x equals the natural log of x. So these two things here and here are the exact same thing. Ln is log with a base E. All right, so if we want to convert between these two forms, what we're going to do is we're going to write each of these equations with E as a logarithm, okay? So here we have in number 1, we have e to the x power equal 24. So if we rewrote this, we could see this as log base E of 24 equals x, which we're going to change this log base E into the natural log of 24 equals to x. And that's something we could actually plug into our calculator. Our calculator has a natural log button, so that's something we could solve for. The other way we could do this that I see a lot of people do, so let's go over to number 2 now, right here. We have e to the 9th power equals x. So one thing that's often shown with e to the 9th power equals x is people like to take the natural log of both sides. So it's like if you did the natural log of this and the natural log of that. what happens here is this natural log and this e get to cancel each other out, basically, leaving us with 9 equals the natural log of x. All right, over here, number 3, if we take the natural log of both of these, what we're going to have is the natural log and the e on that one cancel out, so we have x plus 5 equal the natural log of 72. And that would be something where we could go on to solve that if we wanted to. All right, putting these in exponential form. Since with number 4, since we have this natural log of x equals 58, what we're going to do is we're going to do e to each of these powers. So essentially we're going to do e raised to that power and e raised to that power. In doing that, this natural log and this e get to cancel each other out. So we have x equals e to the 58 power. All right, let's do it over here. Let's do e to that natural log power and e to that x power. Those cancel out. The natural log and the e get to cancel out. So we have 6 equals e to the power of x. Number 6, we have natural log of x minus 9 is 32. So same thing we did if we want to get rid of this natural log here. We're going to raise e to that power and e to that power, essentially canceling these two out, leaving us with just this part that's in parentheses. So we have x minus 9 equals e to the 32 power. And if we go back to our calculator, this is something we can actually solve because e to the 32nd power is a real number. So over on the natural log, if we hit e to the 32nd power, 7.8. So that's something, it is a real number. All right, here we have some properties here. So we're going to do some condensing and expanding. These work the same as the regular logs. So let's look at number 7 right here. We have the natural log of 3 plus the natural log of 16. We're going to do what we've done before. We're going to take this 16, we're going to take this 3, and they're going to multiply in a single natural log. So we're going to have natural log of 3 times 16. That's what we do because these are being added. So this becomes the natural log of 48. On to number 8 here. We have natural log of 63 minus 2 times the natural log of 3. That power property applies. That becomes 3 cubed. So we have natural log 63 minus the natural log of 3 squared. Now because we have subtraction here, we have minus, we're going to do the quotient property. So we're going to have natural log of 63 divided by 3 squared. That's the natural log of 63 divided by 9. And 63 divided by 9 is 7. So we have the natural log of 7 would be this one completely condensed. All right, let's see. That 1/3 is going to be the power of 64, and this 2 is going to be the power of x. So here we have the natural log of 64 to the 1/3 power times x squared. We're doing the times here because these are being added. So if we want this to all be in basically one natural log, one logarithm, That's why the 64 to the 1/3 multiplies by x squared. All right, 64 to the 1/3, let's go to our calculator here. 64 raised to the power of 1/3, which is the same as doing a cubed root, gives us 4. So 64 to the 1/3 power is 4. So we have the natural log of 4x squared. Just like that. Now remember that natural log is an operation, so it's taking the natural log of 4x squared. Expand each of these. All right, in number 10, we have a 5 and an x. We have two things essentially being multiplied. Remember that 5x is 5 times x, which means when we want to expand this, we're going to have logs that add together. So we'll have the natural log of 5 plus the natural log of x. It's expanded. Number 11, a cubed over b, all raised to the second power. This square right here, this is going to multiply by the 3, and it's going to multiply by the single power on the b. So this is going to change into the natural log of a to the 3 times 2, 6th power, over b squared. And now what we can do is kind of a combo deal. What we're going to do is we're going to move those powers out in front, and since it's quotient, we're going to break them up. So we have, let's see, the natural log of a to the 6th minus the natural log of b squared. That 6 goes there, that 2 goes there. So we have 6 times the natural log of a minus 2 times the natural log of b. Completely expanded. All right. Let's do one of these on our backside. So solving for natural logs. Okay, we're going to use the same properties we did before. The only difference now is sometimes we're going to have an e property instead of a regular one. So number 13, since these both have the natural log of both sides, we can drop the log, or you can think of it as raising it e to each of those powers, basically canceling those out. So we're left with 4x minus 27 equals 15 minus 2x. Let's add 2x to both sides. Let's see. Add 2x here. And since our variables are on the left side, let's add 27 here and here. Getting rid of those. We'll have 6x is 42. Dividing both sides by 6, x is 7. Plugging that back in, checking for extraneous solutions. Let's see, if we were to plug this back in right here, we would have 15 minus 2 times 7. That equals 15 minus 14, or a positive 1. So this solution is good. All right, number 14, this 2 goes there. So we're going to have natural log of k squared equals the natural log of 2k plus 15. Raising each of these e to those powers, we have k squared equals 2k plus 15. And now, since we have a quadratic, let's get all of our variables on one side and solve for k. So k squared, moving the 2k over, moving the 15 over, equal to 0. I need two numbers that multiply to 15 and add a negative 2.